Okay, we're going to go over the dot product of algebraic vectors. There's some rules they've given us. We're really just going to apply them to our three-space questions. But essentially, if they've given you something in component form, okay, and you have two positional vectors, the dot product of the two is just taking the x value of both of them and multiplying them, and taking the y value of both of them and multiplying them, and then adding them together to get that scalar. Remember, dot product is just a number, just a scalar. Okay, and if there's three involved, it's the same idea. A1, B1 plus A2, B2 plus A3, B3. A simple idea, okay? We'll jump back up again after, so we'll practice this once. Here's our lovely writing. If I want to find the dot product of A dot B, what we're going to do is we take the first values and multiply them. So 1 by 3 plus the second values, which are -2 by -2, plus the third values, which are 5 times -2. So we're going to have 3 plus 4 minus 10, which gives us -3. Okay? That's it. Dot product of A and B is -3. You have a question? You okay with it? We're about to do a question very similar to it. So, that's the first part. With that being said, we're going to use a bit of the information we have now. For two non-zero vectors, where's the angle between the vectors? We can use this information. So, the next part of the question, whoops, going the wrong way, says find theta between A and B. Okay. So what we're going to do is we know in order to find theta, we can manipulate the dot product formula. In fact, it'll look like this if manipulated. Cos theta is equal to A dot B divided by the magnitude of A and B. Is everyone okay with how I got that? We just manipulated the dot product formula. Okay. But we're missing a little bit of information, all right? Because we're using those components from before. We know A dot B, it's -3, so we already have that part. We know the top of this is going to be -3, but we need to be able to find the magnitude of A and the magnitude of B. Anyone know how we can use dot product to do that? How did we find magnitudes? There's one little trick we learned at one point. If we take the magnitude if we take the dot product of the vector itself, we create its magnitude, right? If I was to take A dot A, we actually get the magnitude of A squared. So in order to find that, we would just have to square root it and we'd have the magnitude. So we'll take our components from above, 1, -2, and 5. That will be our A. Okay, so 1, -2, and 5. This is our vector A. To find A dot A, we're going to multiply this by itself, which is 1, 2 by itself, which is 4, and 5 by itself, which is 25. So the dot product, or the magnitude squared, is 30. So the actual magnitude of A is root 30. Does that idea make sense? So we'll do it again with B. So I can't see it. What is it? 3, -2, -2. So 3, -2, and -2. Same idea. We do B dot B is equal to 3 squared, which is 9, -2 squared, which is 4, and 4. So the magnitude of B squared is equal to 17. So magnitude of B is root 17. So now we have enough information to find the angle between the two. What's that? Oh, I wrote 11. Thank you. 7. Not pi. 17. So cos theta is equal to, remember our number above was -3 over root 30 times root 17. So we just have to find the cos inverse of those values. Somebody, they wouldn't mind. Beautiful. What is it? 97.7? 6? Great. So the angle between the two was 97. I'm just going to write this in for the note. 0.6. That's it for algebraic.